Okay, so hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Okay, now this is our another session in this boot camp, and today we are going to see how to forecast the future sales using LSTM, long short term memory. Before that, let me explain you. See, our objective, as you know, our objective is to understand of how the machine learning, deep learning concept help the ERP or the business, right? That is what we want to explore, right? So first of all, how to predict the future sales. See, in when there were no laptop, no computers, and no internet, how the people used to forecast the future sales. For example, based on historical data. Now based on historical data means, for example, if you see the data, like for the last 5 years, just take a scenario. For the last 5 years, 1 year when the temperature did not go very high in the summer season, that day, suppose I am having a cold drink manufacturing plant, right? Let's take a scenario. Now 1 year the temperature did not go high in summer season, so that year my sale was a little bit low, and remaining 4 years the summer was very high, the temperature was very high, it was too much heating, so the sale was going high. Another scenario, another year, next year, the temperature was low, but the sale was still high. Why the sale was still high? Because one new college was opened, and the college students, there are plenty of college students in that area, so in that area my sale was high. Now my sale is depending on two factors. Number one is the high temperature in summer, or the number of students, right? Any of these two factors increases, they are beneficial for me. Clear? So in this way, not only one factor is responsible for increasing the sale, there could be n number of factors, right? So these n number of factors are responsible for sale. If take third scenario, another scenario, on the next year government has opened a new museum in that city. Now in that city it has become the spot of tourist attraction, so the maximum number of tourists comes, again my sale of cold drink goes high. Now see here, my sale is depending on three factors. One is high temperature in summer, another is college is opened, so maximum number of outside students, then the third is tourist attraction. So in this way, based on historical data, now in future, suppose in future, now how I will predict in future. Suppose government is planning, take any city, right? Now government is planning to open a tourist spot in a particular city after 2 years, right? Not now. And I am planning to open a cold drink plant in that particular city within next year. So definitely it will be beneficial for me, because after 2 years the tourist spot will become ready for, and it will be open for the tourist. So definitely my sale will increase in that area, because based on historical data I know that wherever there are lots and lots of tourists, so there is a consumption of cold drinks. This is historical data says. And in the same way I have predicted the future of that particular city, that if I open the plant for manufacturing, just second, yeah, it is working. Okay, based on historical data I predicted that if in that city, if I open the manufacturing plant of cold drink, definitely my sale will go high. So this is how the human intelligence example, this is an example of human intelligence, that how a person predicts the future sale. But if we talk about the machine learning, right, for this purpose, and the same thing if you want it to be done by machine, in that case what will happen, you have to provide the historical data, right? Each time we have seen so many things right now, PyTorch, regression, everything, all they need is historical data, and based on that historical data they convert the data into two parts, and then the tensors and all the remaining rest is the history that we have already known. And now again we will study in this session also. So with the help of any tool, you need historical data to be given to the machine, then only it will work for you, right? So now in this session also, what we are going to see, we are going to, just a second, yeah, we are going to forecast how this data will show you the forecasting data, right? Just one second. Okay, yes, now here also we will be doing the same thing. So let's see here, and I will show you the prediction of historical data in ERP. Okay, so for example, I will show you, let me show you this also. Here, look at this. This is NetSuite data. Here if I go to transaction and sales and list, this is my sales list of past history, right? I am having the historical data right now, and I have downloaded that data, and I will now explore that data here. Okay, so first of all, let's finish the PPT here. Look at this. What is sales forecasting? Sales forecasting is the process of estimating future revenue by predicting how much of product or services will sell in the next week, month, quarter or year. Same thing I have explained you in my cold drink manufacturing plant, right? So sales forecasting based on historical data and market research. Look at this. Market research, historical data means I have given you scenario 1, that is the summer increased temperature. Second, market research. Market research means the government is opening a museum or the tourist spot, and definitely that tourist spot will attract the tourist here, right? And in this way your sale will increase. Now same, these are the two things. Then is a process of predicting future sales for a business or product, that is fine, help with planning, budgeting and decision making. This diagram is very easy to understand, right? Nothing is difficult here. So this is how we forecast the sales for future. Now preparing sales data for LSTM forecasting. These are the steps for preparing. Now we are having the historical data, and now we are going to prepare that CSV for that particular task. Okay, so now data collection and exploration is the first task, data pre-processing is the second task, and time series splitting, then the sequence to sequence, then future selection, handling seasonality and trends. Look at this, seasonality and trends, 6 point. This is most important. Creating input output pairs, handling in imbalanced data, model training and hyperparameter tuning, and model evaluation and interpretation. I will explain you all these points during this session only. Okay, now see here, sales forecasting benefits. Now what are the benefits? It will be helping in planning sales process also, because once you know that which item will be sold within the next few months in large amount, so in that case you can increase your inventory. For that you have to do the planning, and then in that case you have to improve your sales process. Then sales team will also work hard for that. Technology, obviously technology plays an important role in that. Then demographics also decides in which part of the city or the country your item will be sold. Economy, definitely economy will get benefited on it. Now see here, process to predict future sales. Process to predict future sales. First of all, you get here the raw data, then data cleaning, label encoding, merging, clustering and pivot table, right? these are the techniques with the help of which we predict the future sales. Pivot table, those who are expert in Excel sheet, they use pivot table techniques. Then light GBM, and then the stacked LSTM, and then the MLP with LSTM encoder, then root mean square error. So these are the three techniques with the help of which whatever are the output comes. Root mean square error is also defined. Now see here, pre-processing, building model, and evaluation. These are the three main activities that we are going to do. Okay, now let's see some practical part. I have already, now I am creating a IPyNup file, interactive Python notebook. Okay, now look at this. I have already downloaded this Excel data. See here, this sales data I have already downloaded somewhere here. Look at this, ERP sales, right? You can see here date and sales, only two columns are there, right? Date and sales. Why? Because only these two are needed. So what we do, first of all, to work on that data, we need some important libraries here. Here are the two libraries, no, not two, many libraries we will be using. Pandas SPD, a very well known library used for data cleansing and massaging. NumPy NP, another important library. Matplotlib, PLT for plotting the graph. Torch, inside the torch.nn, that is the neural network. sklearn for min max scaler, right? So now what we are going to do, we have to wait for 2 seconds, 3 seconds, and then let's see, once all the libraries are pulled, then it would be easy to understand exactly which data goes from where to where. Okay, now, okay, it is still still processing. So now what we are going to do here, look at this. First of all, we need to load the data. Let's wait here. Yeah, it's done. And now we are going to load the data. Now load the data means exactly what? See here, load ERP dataset. Now load ERP dataset. Now as I have shown you only date, so we have to convert it into date, right? So here you can see pd.read CSV, this is the sales CSV, then df date, date is the column, pd to date time, df date. Okay, so df sort values date, that means in ascending order it will sort the value. Okay, now df head, suppose if I do it like this, df, how many records are there? Okay, now what we need to do here, see aggregate and scale. Now if I copy this and paste it, now see what's written here, df monthly equal to df group by date sales sum reset index, and then scalar equal to min max and the df monthly, that is sales scaled scalar. Okay, see what's written here, df monthly. Now see, we have to, the date is given, we have arranged it in ascending order, that is also fine. But one more thing we need to do, we need to arrange group by, that means November month data in one place, right? So we have to do this grouping, group by date sales sum dot reset index, scalar equal to min max scalar, this is a function min max scalar, and df underscore monthly sales scaled, right? sales scale scalar dot fit transform. Okay, df underscore monthly, say 1 minus. Okay, so here you will see df monthly. Now let me df, look at this, dates and sale. Okay, now what will happen here, we have to create a sequence of LSTM. See, LSTM is a new concept, so just watch it very carefully. Create sequence for LSTM. Now sequence length, that is 12, right? And definition, create sequence. This is a definition of creating the sequence, right? You can see here access, append x, append y. Okay, look at this. So x y equal to create sequence df monthly sales scaled value sequence length, and here you can see one, 2, 3, 4, 5, 10, 11, 12. Look at this. You can see here sequence length, that is 12, right? So you can see 1, 2, 3, 4, 5. Same thing is here, right? So set of 12. So it is a dictionary created, right? After that you will see xs and ys, and we have put into xs here the data in create sequence. So you can see here all this data is now created. Then we have to train the tester split. You have to train it. So what's happened here, x train, x test, y train, y test, x split, x split, y split, y split. Now you will see here now sales data set. Now here we have created the sales data set, in which with the help of this tensor code we are converting the Excel sheet into the data set. Okay, now you can see here sales data is a function, right? So train loader and test loader. Inside this train loader, x train, y train is loaded, and x inside this what we call as test loader, that is called data loader sales data text equal to bracket x underscore test comma y underscore test. So these are also available here. Okay, now let's move ahead. You can see here LSTM model. So we are going to create a LSTM model, right? Now here the LSTM model shows that neural network dot module. Okay, and then here you are creating input size is 1, that is the date size, and you can see here hidden size is 64, that means it's a random forest. No, not random forest, we are using neural network, right? So in this neural network we are using 64 neurals. These are the number of neurals that we are going to use, right? After that self dot LSTM equal to nn dot LSTM. We are providing here all the neurals, right? After that forward. So what we are going to do here, just a second, return model equal to this. Okay, and then criteria is MSM. Here is, now you can see torch.optim.atom model parameter, right? This is mean square loss, right? Now our next target will be, look at this. Now let's come to training the loop. Okay, so this is our most important and interesting part, that is training the loop. Now we are running the 30 epochs. Epochs means the repetition. For example, if I come to you daily, so at least I need 90 days or 100 days to understand your behavior. The same thing is here. It makes itself intelligent due to the running data, and also comes to the whatever the additional data. So in this way 30 epochs we are running. Then here look at this train loss. Train loss is right now empty. Model dot train, train dot total dot loss equal to 0. Okay, after that what will happen here? We have executed the epochs, right? And then this epochs will run, and finally you will see here it gives you the output that the loss is decreasing. Look at this, the loss is decreasing, where previously it was 0.33, so 0.29, right? So in this way we have increased our efficiency and the loss is decreased. Now see here, look at this. Now we are going to plot this data. Now how to plot this data? Let's wait for 2 seconds. This is the same library that we are using here, right? So as the number of epochs are running, and here the loss is reducing, right? So the more number of epochs you run, the more number of chances of success, and the loss goes down is more, right? After that, just a second, here you will see we have plotted the data. Now we are going to evaluate our data. Now we are going to evaluate our data because how much actual or how much accurate it is, right? So this is a function we have written eval, right? And predictions actual, both the arrays are empty, right? So this is the function that we have written for evaluation. Evaluate. Okay, now let's go here again, import. Now again look at this matplotlib pyplot, build a full time with both actual plus predicted. Now we are going to create both actual plus predicted. For what we are doing this? We are doing this for this purpose. Look at this. This up to this point it was historical. After this point it is suggesting that in future sales will go a little bit high than whatever is today. Okay, so now here you can see up to this red color line forecasting is started, and before that with the help of machine or any other means they might be calculating this. Okay, so now we will see here at this point, you can look at this, at this point it is increasing. Okay, now one more thing that I want to show you, just a second. Yes, here it is. Now see, forecasting future sales. Now we are going to forecast the future sales. Okay, see, then look at this. Forecast future sale for what? For this we have to do one thing, that is start from last unknown sequence, and then last unknown sequence equal to torch.tensor x minus 1 data type equal to torch.flowchart float 32, and then the unsqueezed 0. This is a standard formula, you don't need to go in depth in it, right? Just apply this formula, right? We don't need to do some extra efforts on it, we just apply this formula here. After that, forecast. What will be the value of forecast? So here, just a second. Forecast equal to scalar dot inverse transform NPRA forecast scaled, right? So these are the forecast methods, right? Then price per unit, that is 30, and forecast revenues, forecast multiplied by price per unit. That is what we are doing. Okay, now here if I show you, this is the timeline. Let me show you the timeline. Now look at this. This is what it is showing with the help of this data. Suppose wait, here it is. This is the historical data up to blue color, and this red color, it shows the next data, that is the forecasted data. Now forecasted data is showing that it will go down. Okay, now see here. Let me plot this figure also. Look at this. We have just increased this data. We have just zoomed in this data. How this data is looks like. So this is what the smaller image I have converted into this large image, right? So this is showing the loss here. Look at this, 2025 to look at this up to this. So let's have a quick recap first, because in one attempt it will be very difficult for those who joined it for the first time, right? Now see here what we have done. First, we have taken the data from NetSuite, that is sales data, right? I have downloaded data from this NetSuite. Then what I have done here, I have read the Excel sheet first, and then converted the date time in a proper way, right? Group by, and then grouped by the sales by the date, group by date, right? And then after that, what we have done here, the create sequence formula is done. Formula is written that created the sequence in the set of 12 dictionaries, right? So these are the set of 12 dictionaries, right? And then split the data into train and test. Yes, train and test, that is fine. And then class sales data set. Sales data set means exactly here in it self y and self x, right? Digit equal to minus define. Yes, minus define. Look at this. Train loader equal to data loader, and sales data set x train y test, right? After that, what we have done, LST model. Look at this, right? LSTM model. After that, we train the loop, that is the epochs, and then this epochs is executed, right? 29 times, total 30 times. Okay, and after that, plot testing data. Plot training data means plot remains trains losses and trains training loss and the epochs, everything, right? After that, we evaluate after that we evaluate our data, our model. We evaluated our model. Okay, we evaluated our model. Here you can see this function, right? So here you can see the actual, right now both the arrays are empty, so actual values of every item, right? Actual value of every item is loaded. Okay, After that, you will see the matplotlib is used for forecasting the historical data. Same thing is here, historical data is feeded here, and then it will show you the trends, right? This is you are going up, okay. Then you will see forecast future sales. Now forecast future sales means what? In future how much your sale will be done. So for that we have to create a scalar dot inverse transform, right? And then we have to extract. Look at this, price per unit, and then the forecast revenue equal to forecast multiplied by forecast price revenue. Then we will see here the future dates. Now you see, okay. Now finally what we have done here, we have taken the timeline and we have broken this timeline here. This timeline is showing the downside, right? Look at this, the same line I have plotted here, right? So here what it is doing, revenue should increase, right? But it is going down. Forecasted revenue, this is the forecasted revenue for the next 6 months, right? So in this way we manipulate on data, right? We can manipulate on data, but for that we need practice and accurate knowledge of which function is used where, right? So guys, today we are concluding here only, and I recommend you to watch this video twice, thrice, because in one attempt nothing happens, and you have to watch this video twice, thrice, then only it will be understandable. And those who are coming or joining this bootcamp sessions for the first time, then please subscribe the channel. Okay guys, see you on Monday evening. Thanks for attending the bootcamp.